May we now have the fourth speaker. It's a great pleasure for me to introduce our next speaker tonight, who is going to talk about bioenergy. He is from the International Rice Research Institute headquarters, the world's premier research organization that involves rice science. He is an experienced young assistant scientist at the Mechanization and Post-Harvest Cluster Sustainable Impact Platform, who has main specialization in agricultural mechanization, post-harvest, and agronomy. He helped in many ERI extension activities that provide trainings, seminars, and workshops for rice technology dissemination. He has also served as ERI expert on national partnerships projects. Currently, he is ERI's representative to the Department of Agriculture, Philippine Council for Agriculture and Fisheries. He has also many awards, but the most prominent are the 2016 Distinguished Young Alumni Awardee of SEAT UPLB and the 2018 Scientific Achievement Team Award issued by ERI. Our speaker is a graduate of Agricultural Engineering, major in Agricultural Machinery from the University of the Philippines, Los Baños, and is currently pursuing a master's degree in Agricultural Engineering, major in Agricultural Farm Power and Machinery at the same university. To his college and friends, he is known as ODEP. Ladies and gentlemen, let us all welcome Engineer Joseph Sandro.
Good evening to everyone. Thank you for inviting me. I'm glad to share with you what we are doing at Erie with regards to bioenergy. Is my sound clear?
Yes, sir.
Okay. If my because my signal is unstable, so if it continues, I will just remove my camera. Okay. So many of you probably already know what Erie is, as Sean mentioned earlier. But for those who are new or for those who are not familiar with Erie, it is the International Rice Research Institute. So basically, we are part of the CGIAR, or the Consultative Group for International Agricultural Research. So Erie's main headquarters is at Los Baños, Laguna. But we have several country offices across Asia and Africa. Basically, we are doing rice research, and from as basic as gene editing as to as far as policy recommendation. So for this talk, I will be sharing with you our activities or research activities with regards to rice straw as sustainable source of energy. So I was given a topic on biomass, but I told the organizer that I can just be talking about rice straw, as it is uh, our researchers will focus. So to start, biomass industry in the Philippines is advancing rapidly. Biomass refers to the biological material that can be used as fuel, from as simple as leaves to more complex like alcohol. So today I will be sharing with you researchers we've done with regards to rice straw as a sustainable source of energy. So these are let's what are the opportunities that rice straw offer or can offer in terms of energy production? One of the neglected potential source of energy, not just in the Philippines but in all rice producing countries, is the rice straw. In rice production, we can see in the figure that many activities or processes were involved before we see the rice or our kanin on our plate. When rice crop is mature, then it is harvested. The grains then needs to be dried at the right moisture content to be stored, then milled. So milled rice will now go to our supermarkets, then to our homes and our tables. Within these processes, we have different byproducts. After harvesting, we have the grains and the straw. Then rice can also be sold as seeds. If we mill the rice, then we have the milled rice, the husk, and the bran. So we will focus just on rice straw. As a rule of thumb, rice straw and grain or paddy, most of us know, has a 1-to-1 ratio. So it means if we have 10 tons of harvested palay, the rice straw is basically also 10 tons. So in the Philippines alone, we can have around 11 metric tons of rice straw in a year. So in Asia, it's around 60 metric tons in a year. And then imagine that almost 60 to 80% of those rice straw are just being burned in the field. That cause pollution and increase the greenhouse gas emission. So here, we have two methods of harvesting rice. So basically, it's the manual and mechanical or using the combine harvester. In 2019, Piri and Phil Rice conducted a study on the status of harvest and rice straw management in the Philippines. We found out that manual harvesting will cost at about $300 or 300 US dollars or around 15,000, while combine harvesting will cost between 100 to 120 US dollars. Oops. Or around 5,000 to 6,000 pesos per hectare. So from this figure on the right side, we can see that those farmers with relatively small farm sizes are those who practice manual harvesting, while majority of farmers having relatively larger farms opted to use combine harvesters. So the study also found out that not all provinces, so basically we did this study in uh, 6 provinces in the graph that you can see on the below, and we found out that not all provinces have the same practices in the rice straw management. For the case of example of Isabela, almost 90% of rice straw is being incorporated back to the soil, while in Nueva Ecija and Bukidnon, as you can see on the graph, rice straw is either incorporated back to the soil or being burned in the field. So, in detail, I will show you with this graph the utilization routes of rice straw. So from harvesting, we have different field options. We can burn it, use it as a mulching material for other crops. We can just incorporate it back to the soil. And another option is to collect the straw to be used in other off-field options. But it needs some pre-processing procedures before we can utilize it or we can utilize efficiently in other uses like agricultural. We can produce energy and to be a material for other industrial uses. So then um, we also have problems in rice straw management. If you know, or for those who are familiar with combine harvester or combine harvesting, this is actually a game changer in rice production. Why? Since its introduction in the Philippines way back something like in 2000, it helps a lot of our farmers in mechanizing their harvest procedure or or their rice harvesting. But at the same time, it also creates another challenge. So the quick turnaround, the quick harvesting time for our field left the straw just in the field. And there is yet at this point in time there is limited machine in the Philippines to collect or designed to collect straw in the field. So our farmer are left with the option to burn or just leave it to incorporate to the soil during land preparation on the next cropping. So we as researchers, we go back to our notes and think again, what is the best option for farmers, which is more sustainable? So this is a complicated figure, but we studied the different management practices of farmers for straw and what will be the best practices. Some do incorporation, some do burning, some are removing straw partially. And what if the scenario, the fourth scenario is we completely remove the straw to make, to use it in other uses like energy production or mushroom production and other uses. So in 2015, we did an experiment and we look at the possible effect on the environment of these scenarios. So we measured the greenhouse gas emissions on these processes, like during harvesting, what is the amount of carbon dioxide emitted by the combines, by the machines that the farmers are using in burning, in incorporation, and even in baling. With our setup in the field, the what we call the eddy covariance system, we can measure different gases like the methane, the carbon dioxide, and also with a very simple equipment that is we made is the gas chamber. So we did greenhouse gas emissions on these processes, and we found out on this graph you can see that after collecting these parameters, we analyze it and make this as a graph. And then if you can see on this graph, the y-axis or the vertical on the left basically is the net energy balance in terms of megawatt hour per hectare and the annual greenhouse gas emission in terms of megagram carbon dioxide equivalent per hectare. So in terms of net energy that can be produced from rice straw, we can have around 1.34 megawatt hour per hectare. So it's roughly around 130 US dollars when we convert into amount of money. And then with regards to the greenhouse gas emission, it's very surprising to us that the complete incorporation, meaning if you return the straw into the field like um, completely, it will emit more carbon dioxide compared to open field burning and other practices like partial straw removal and complete straw removal. Actually, this data is intriguing, and if you will follow the script or the manuscript that we published, there are lots of questions and discussion with regards to this because the assumption of most of people or scientists is that open field burning or burning creates or emits more carbon dioxide than other practices in rice straw. But this study really gave us a different picture, maybe because of the other processes involved in degradation of the biomass when it is incorporated in the soil. So we also did the life cycle assessment in all those management practices. This is another way of presenting the data in comparing the different options. So the question is burning good or is straw burning good? So in terms of greenhouse gas emission, comparably same with other practices, but it was very high or it is on the highest scale in terms of human toxicity. So you can see on the table the different particulates and other parameters that were emitted during straw burning that is very toxic to our to us, to humans. And in other practices like complete removal, complete incorporation, partial removal. So the green one is the partial removal. So they are relatively lower. So it means that for the case of straw burning, we can still use that to generate energy, but we should be careful on the device or on the equipment that we are using. And then on the study, we also tried. That's why we tried the existing furnace, which is or rice hull. So at Erie, we have this one, and then we conducted this research on this down drop rice hull or rice straw furnace for paddy drying. And we found out that the heat energy efficiency will be roughly around 60%. So it also in 2013, 2012, 2013, we conducted a feasibility study with Enertime to look on the possibility of having a 1 megawatt power plant completely run with rice straw and other biomass like coconut husk or coir that is very present or very available just in Laguna. But the problem is, or the challenge that we encountered is that due to risk of securing the rice straw from the surrounding, it was not implemented. And then we also developed another option for energy production with the use of digester or anaerobic digester. So this plastic is what we call the hermetic plastic or the hermetic storage. Actually, this is used for rice storing rice. And what we've done is to use this to store the biogas that is emitted during anaerobic process. So this is a low investment. It has a low investment cost and it's very portable. But the limitation of this is just for household. We can just made it for a household scale. Now, with all these opportunities for rise through a sustainable energy source, what are the challenges that we are still facing? So these challenges open another door of opportunities for us as researchers. Um, in the value chain of rice, there are still some bottlenecks. Number one is in the collection part. As I've said earlier, there are very few, or even we can count maybe on our fingers the number of rice straw bales in the country right now. Next is on the compacting or the storage, or even in transport and in markets. Okay, sorry, and also in markets. Oops. But we will not be stop. We will not stop on these challenges. We will continue as engineers and researchers to innovating things. Like for example, in Vietnam, straw collection or straw balers is very common right now. Um, in 2000, this technology is just promoted in Vietnam in 2016, also part of our project. And in 2019, about almost 6,000 balers were already there. So in our study, it reduced around 20% of rice straw in field burning in Vietnam. Okay, so maybe I don't know if it's playing on your no screen, but these are the sample machines that can collect rice straw directly from the field. And then another problem is because rice straw is a loose material, we need to densify it to be transported efficiently. So we are also looking on the reducing the cost of transportation when we do densification of rice straw like straw baling. And another another technology is briquetting and pelletizing. So in briquettes and pellets are being used also as the rice straw is being made to briquettes and pellets first, then used as an input to power plants. Those power plants who are designed um, to generate power or energy using biomass. With all this vast array of actors and processes involved, how to optimize the logistical no, problem and matching between supplies and demand. So if you can see on this graph, there are lots of actors and other um, processes that involves in rice straw management. So it opened another door for us as researchers to think of how to really solve this problem or solve this challenge, how to optimize the logistics and match the demand and supply of this product. So what we've done is we made an application. This is a mobile application that you can that help us to optimize the scheduling of the different machines like combine harvesters for balers and other logistic for paddy and straw. Actually, this project is now being piloted, and the Department of Agriculture with the Bureau of Agricultural Engineering and Fisher Bureau of Agriculture and Fishery Engineering or BAFE is we will be having another project to incorporate all machines like tractors and other machines that they distributed or the Department of Agriculture are distributed to farmers. So with all this, I will also share with you some of our projects past and ongoing in terms of that we deal with rice straw. So we have the Enertime project. What I've said earlier, the feasibility of rice straw as a source of power or input for a power plant. We have the rice straw energy project from Supergen and other projects. We also collaborate in different universities like in Hohenheim, Manchester, and of course our national partners, uh, the Philippines, number one, and other Southeast Asian countries or Asian countries, and also in Africa. So with that, I would like to thank the organizer, the class. Thank you very much for inviting me or sharing with you some of our activities with regards to rice straw and biomass or bioenergy. Thank you.
Thank you, Engineer Joseph, for the great presentation on bioenergy.